Okay, so this is the problem that we did in class today, and I'm going to go through each version so you can check your work. So this is the one where I'm going to actually calculate the p-value. And so of course I have the hypotheses, I have the name of the test, and I've checked the conditions. So now I'm ready to do the work with the sketch and the calculation and then my conclusion. So I drew my bell. Remember, in the center goes mu of x bar, because this is an x bar bell, and the standard deviation for x bar. And then here's my individual sample that I got. So I need to calculate the z value for it using my formula x bar minus mu over sigma for x bar, and I get 2.73. And so I want to know what the area is to the right of that. And so if I go look it up in the table, of course I'll have to do 1 minus whatever the area is to the left of 2.73. And in my calculator, of course, I could actually use normal CDF and then do 2.73 to infinity, and then that actually would be sufficient. Remember, mu is equal to 0 and sigma is equal to 1 on this normal bell, because I've created a standard normal when I'm looking up z-scores. And then I get this value, and that's the area to the right, the stuff in green. Now I will even shade it purple. And since it's only a single-sided test, because my alternative was greater than, I do not need to double it. So don't double. And now I'm going to compare my p-value with alpha. Remember, in class you said you didn't have a significance level, so I gave it to you. And since my p-value is smaller than that, then I must have fallen in the reject zone. I'm going to reject. So this is what the conclusion will look like. So since my p-value is 0.000032, I can reject my null at alpha equals 0.01, because only 0.3% of the time would I get an x bar that extreme, and therefore I will conclude that those 8th graders in fact are above the average, above 83.2.